afternoon, everyone. Thank you for coming back after the coffee break. As Jean-Luc warned you, I will be speaking in English, but you're certainly welcome to ask any questions in French afterwards, and I will try to answer in French without making too many mistakes. So I'm going to talk about the speech processing technologies, or sort of give a highlight of the technologies developed in Quaero. I obviously can't go into everything, but I'll try and highlight some of the most important advances. So with, as we heard earlier, when Quaero started, there was the web that existed, but there was a lot less multimedia, a lot less varied data on the web than there is today. And so it's really great to have this data. We can store it, but if we can't search it, if we can't find things in it, it's not very useful to us. And so one of the goals we had with Quaero was to facilitate searching in these huge corpora of audio and audiovisual documents. So one thing coming from the speech side, of course, people in image will say images are everywhere. Well, speech is everywhere. And speech has a lot of information content, and so why not try and use this to find relevant portions of the audio documents? And then if we can convert the speech to text, we can use the many, many years of research in text processing and apply this to speech. So there's a lot of applications with audio visual media analysis, media monitoring, closed captioning. With the recent rules in Europe and needing to closed caption almost everything that's displayed on TV, there's a huge demand for speech recognition in many European languages. So there's a lot of technical challenges we face. One of the most important, and it was interesting, we saw that in text just a few minutes ago, one of the important factors was the variety of documents. Well, for speech and audio, we have a similar situation. There's a wide variety of different types of audio documents, the languages, the speakers, the background conditions, and all this affects the speech-to-text performance. So this is something we need to work on, the different challenging conditions that we have for audio documents. Another challenge is reducing the development costs and the time. Performance is, of course, an issue. And going beyond transcription, can we extract further information from it? Once again, many times using the same types of analyses that are applied to text documents, but we can use other features that are in the audio, such as intonation, that can help us, that is not available when you just have to analyze text. So some challenges, as I mentioned a few minutes ago, is processing all the different types of data. When we started, we already had technology to process what we can call more professional data. So news that we see on the radio and TV, or hear on the radio, see on TV, was already available for a few languages, not too many. But we're also interested in amateur documents, which are much, much more varied. We wanted to cover many European languages, and in fact, during the program, we extended the many, which I think was 9 or 10 at the beginning, to be 22. We want to be able to determine which language is being spoken in an audio document. So that's referred to as language ID or language recognition. We want to identify and track people in the audio documents. So this is speaker ID or speaker diarization. And one important factor is to compare how well systems do to humans. So can we reduce the gap in performance between systems and humans? And I guess the one really important point for Quaero was, can we create successful applications? Can we use the technologies even though they are imperfect? So how can we get around this and develop interesting applications with these technologies as they are? So here's a quiz for you. Of course, I can't see you. How many languages are there in the EU? So we have 3 choices here, 23, 32, or 60. So can I see a show of hands for 23? Anyone? Okay, 32? 60. Well, actually, it's a trick question. You're all right. Okay, so there's 23, if I'm not wrong, official languages at the European Union. There's 32 official languages in one of the member states in Europe, if it hasn't changed since I did the count. And there's 60 if you count the official regional languages, but in fact there's more. And so if you look at a map of Europe or extended Europe and which languages are spoken, you actually see there's Russian, there's Ukrainian, there's other languages that filter in. And if you consider the immigrant population, we get languages like Turkish or Chinese or Arabic that are very common in many of the European states. So actually, Alex, if you're here, thank you for the figure. So this is from a talk Alex and I did a few months ago, and he had this figure. So to highlight the speech processing technologies, you have some audio signal that comes in. I don't know if we have a pointer. It doesn't matter. So an audio signal that comes in. We can, first thing we do is we want to divide this one. I don't see it. Anyway, so the first thing you want to do is you separate speech from non-speech. Then you might want to identify the language of the document, or transcribe it, or do both. You might want to go and try and detect who's speaking in the document. So that's the upper right there. And you might want to do things to make so typically when you get out a written transcription of speech, you get what people said, the words. But you also want to maybe get punctuation. You want to get case. You want the output to look more like a written text that people are used to. And of course, you might want to translate it, and you'll hear about translation in a few minutes from Herman in the next talk. So another important issue is performance. So how good is good enough, or what's good? In Quaero, we did annual technology evaluations of the different technologies developed in the speech processing work package. So we had speech to text. The measure for that is typically the word error rate. So it means, is there a mistake, a substitution, a deletion, or an insertion of a word? We also have, sorry, I missed there. We want to compare, to do this, we compare the output of the system to a human reference. And then we measure how many different types of errors there are in the output. For speaker diarization, what's measured is called the diarization error rate, which is a weighted sum of the false alarms and misses. You either assign frames of audio to the right speaker or the wrong speaker. Or you miss assigning some frames of audio to the speaker. And for language recognition, there's many, many different measures that have been proposed. It depends on if you do an identification or a detection task. And so those that are interested can see some of the benchmarks that are run by NIST. And I don't have time to speak about the language identification today. So getting back to what's good enough, a rule of thumb is that if you're looking for searching or indexing, a word error rate less than 30% is maybe good enough. If it's lower, it's better, but in that range. For closed captioning, most people say they want under 3% error rate. That's very low. Humans are probably 1.5% to 2% if they transcribe texts. And for translation, also it can be as low as 3 to 15% it becomes usable. So the 15% for the captioning is in the case where it might be better than nothing. So people that really can't hear might prefer to see something with about 15% error rate, and it's good enough for them. If it gets much higher, they start to really lose the content. So there's real errors there. So in this slide is talking about the tasks and the partners we did in Quaero. So I spoke about speech-to-text transcription. We had 4 partners, 2 German, 2 French in this. We focused on 3 main languages for Quaero, so French, English, and German, which were evaluated all the years. We had 6 evaluations for this. We progressively increased the number of languages to 9, and for these 9 languages, Quaero actually did corpora collection and for training of the systems and for testing, development and test. As we went along in the years, we increased the task difficulty. So instead of having data that was well prepared, we started looking at more interactive data, debates, television interviews, and more varied web data. So the later data we used in the project for evaluation is much more challenging than what we used 5 years ago at the start. Also, 2 years ago, we started to say, hey, we do a really pretty good job on these languages. Let's try and extend the number of languages. And so we did for, I think, 14 languages, we collected just development and test data. So no training data, and said to people, try and evaluate on this, see what you can do, gathering whatever resources you can find, and doing systems without manually transcribed data. So let me then go to say a few words about speaker diarization. We had 3 partners, LIMSI, KIT, and Vocapia. And this is also referred to as the task of who spoke when. So it's segmenting audio into different speaker turns and grouping them together. And at the time that Quaero started, there had been evaluations on this, on both meeting type data, so conversational sitting around a table, and also on broadcast data. Those were the two main focuses. But it was always within a single recording. And something we explored in Quaero was to look across documents, and we call that cross-document or cross-show diarization, and try and find all occurrences in maybe a large audio archive of a given speaker and associate portions of speech to the speaker. And then finally, there's language identification that I won't say anything more about today, but you'll hear, I think, a little bit from Bernard in the next talk. So here's an overview. There's a lot of information here, I guess. It's the average document word error rate. So I said before, word error counts the insertions, deletions, and substitutions, the three types of errors that systems make. The first 9 languages on the left are the languages in Quaero that there was somewhere between 50 and 200, maybe more, hours of audio training data that was transcribed, distributed to the partners in the project. The next 2 are, so that's the Polish, Spanish, French, etc. Next, we have Dutch and Czech, and those are 2 languages that we only did development and test data, but these 2 languages, there are some corpora out there, so people could find manually transcribed data to train their systems. And then the remaining of these on the right, starting with Czech and Romanian, etc., are all the languages that we only had dev and eval data, and there were no resources that we knew of available to train systems. So these systems all on the right were trained in what's called unsupervised manner. So we found text, we found audio, and we used a system to help us train a system. So that the system was learning itself from the data. So this is the average document error. That's a little bit nicer. So you can hear the error rates around 10–15% for the first 9 languages, about 20% for a bunch here, and there's one that's about 35, the Bulgarian. But that's not the whole story. If you look at that's an average, but if you look across the data types, we can see in green the minimal error rate across the different types, the different languages, and we can see some of the files are actually down at about 3%, 5%, what people want for captioning. But the worst ones are pretty bad. So for almost all languages, there's at least a few files that are up in the 30 to 40, even 60% for some. So why is speech processing different? This is inspired from a slide that I had seen from Tanya Schultz, who also participated in the speaker diarization work from CMU and now KIT. So we have a text, but when you speak, it's continuous. There's no spaces between the words. And when you speak spontaneously, you don't say, I do not know why. You say, I don't know. And so once you get to a pronunciation, you can see there's multiple pronunciations for a given sentence. And the system has to put all these together. So it's very varied. As we saw with the documents, we have this for audio. And so here's some of the factors. It depends on the speaker. It depends on the gender, the speaker's accent, how they feel. Are they nervous? What environment they're with. Do they speak with someone they know, someone they don't know, etc. Same thing for the acoustic environment. Is there background noise? Is there a car? Is the TV on? Is there babble in the background? These all can have a very big effect on performance. So here's now a study that was done at LIMSI trying to see how humans do at transcribing speech. So the green and the blue curves here, which I unfortunately can't point again, are levels for French and English where the speech recognition, thank you, Herman. The speech recognition system, oops. Yeah, it does, but I don't see it. That didn't work. Anyway, the mouse doesn't show up. Anyway, so the blue and the green are where the speech recognition system did not make an error, and you can see humans do very well. That's sort of like a residual error rate. What you see here is that humans judged transcribed words based on either a 3-word sequence, a 5-word sequence, a 7-word sequence, or a 9-word sequence. So the first thing we can see is that humans, once they have 5 or 7 words, they do about the same. But 3 words, they make many more mistakes, about 5 times as much as what they do with the 7 words. And these are, then the red and the yellow are curves where the recognizer made an error. And we can see, in particular, in that case, humans have a much harder time. So with a 3-word context, humans make a 30% mistake on that middle word, transcribing it. Without a wider context, if the system made a mistake. So what's ambiguous for the system is also ambiguous for the user. One other point I would like to make on the slide is that when we talk about that systems degrade in noise, well, humans degrade in noise also. But humans, their baseline error rate is maybe 1%, 2%. So if you double it in noise, you're going to 4%, 5%. It's not so bad. But a system, if they're at 10 or 12%, if you double that, you go to 25%, and that's really noticeable. So I said those points. So I want to say a few words about who spoke when, which I probably said most of. The main point I wanted to make on this was that we did 2 innovative tasks. One is looking for what we called VIPs, so personalities, and the second is trying to look at speakers across shows, as I said. And once again, there's a fair amount of work trying to combine the modality of speech with video. And this is just a slide showing how you can use it. This was from the US elections, and up there is a pie chart showing the time for different speakers of the personalities in the different news at the time. So let me just say that we made what we consider to be major progress. We went from roughly three languages at the start of the project to 22 at the end. We have lower error rates on more difficult data. We've reduced the development time, and we have shown that for at least several broadcast-type data, we're able to rely less on annotated training data. So we need less of that. We can develop systems faster. There's still a pretty big performance in human and machine, difference in human and machine performance. Our models are not very good at using world knowledge or semantics. So for example, punctuation is important. Here's a sentence that we see the words there. Depending on the punctuation, there's a very different meaning. So this goes to what Jean-Luc Jankowski said a few minutes before. This comma can be very important. So woman without her man is nothing, or woman without her man is nothing. And so the interpretation of this is very different, but there is intonation that, obviously it's a sort of toy book example, but the interpretation is very different depending upon what intonation you have. And so I hope that you saw some demos and you will see some more about building successful applications with our imperfect technology. So thank you.
Ok, merci. Donc, je vais vous dire quelques mots sur les modules technologiques du traitement de la parole, essentiellement identification de la langue et transcription de la parole. Alors, ces deux modules font partie intégrante de la suite logicielle Voxenma dont je veux parler ce matin, et ils ont tous des caractéristiques en commun, y compris la segmentation audio, qui est le premier élément de la chaîne, mais je ne veux pas m'étendre là-dessus, Laurie en a dit quelques mots. On a deux types de systèmes, ceux qui sont destinés aux données radio-télé et ceux qui sont destinés aux données conversationnelles téléphoniques, qui sont beaucoup plus difficiles à traiter. Tous ces systèmes acceptent en entrée les formats qui sont indiqués ci-dessus, et c'est des logiciels qui tournent sous Linux. Mais comme je le disais ce matin, on a aussi maintenant le système sous forme de web service. Donc il y a un intérêt technique, c'est qu'il est beaucoup plus facile, en particulier pour la transcription de la parole, d'avoir des modèles rapidement à jour. On peut faire des mises à jour quasi quotidiennes en fonction des nouveaux mots de l'actualité. Et puis, c'est intéressant aussi d'un point de vue commercial, puisqu'on peut toucher beaucoup plus de personnes qui peuvent faire facilement des tests sur nos systèmes, commencer par s'abonner au système avant éventuellement d'acheter des licences s'ils veulent avoir beaucoup plus de données à traiter. Pour l'identification de la langue, il s'agit donc de reconnaître quelle est la langue parlée. On a un système avec 30 langues sur les données radio-télé, 50 langues sur les données téléphoniques, mais on commercialise également la possibilité pour le client de rajouter lui-même des modèles de langue au système. L'intérêt, c'est d'orienter les bons documents vers le bon interprète ou le bon système de transcription. Et les applications, il y en a aussi bien en défense, centre d'appel et les diffuseurs radio-TV. Transcription de la parole, bien Laurie en a parlé tout à l'heure. Au début de Quaero, on avait 4 ou 5 langues. Maintenant, on en aura à la fin de Quaero, on en aura 25. D'une part, on a utilisé pas mal de corpus dans le cadre de Quaero. Et comme le disait Laurie aussi tout à l'heure, les méthodes d'entraînement des modèles ont progressé. On n'a plus besoin de corpus exacts avec leur transcription pour entraîner les modèles. On arrive à des choses qui convergent et ça permet d'aller beaucoup plus vite. Ce n'est pas encore le cas pour le conversationnel téléphonique et on n'a que cette langue. La transcription de la parole, donc un des principaux intérêts, c'est de transformer les documents audio en documents texte pour bénéficier de tout ce qui existe déjà pour le texte, indexation, détection d'entités nommées, on en parlait tout à l'heure. Au début, la plupart de nos applications, c'était des applications d'indexation parce que la reconnaissance fait des fautes, elle en fera toujours, et malgré les fautes, pour l'indexation, ça peut servir à quelque chose. Pour faire de la transcription exacte, on nous disait à l'époque, et ils avaient raison, que ce n'était pas vraiment rentable de corriger des fautes qu'on n'a pas faites plutôt que de taper from scratch. Il s'avère que maintenant, ce n'est plus le cas. On a bien progressé dans les taux d'erreur. On est largement en dessous des 30% pour ce type de document. Et on a de plus en plus d'applications pour des transcriptions exactes. Les applications, c'est la défense, le media monitoring, le speech analytics dans les centres d'appel et, je le disais, les services de transcription avec 2 exemples. D'une part, c'est notre système qui est utilisé pour faire des sous-titres automatiques avec quand même correction manuelle pour la télévision des Pays-Bas NPO. Et il s'avère que pour la plupart des programmes, c'est tout à fait rentable. Les programmes de divertissement, les modèles ne sont pas efficaces. Et là, ils les font toujours à la main. Ce n'est pas la peine d'utiliser notre système. Et puis, je voulais, dans le temps qui m'était donné, vous montrer rapidement un petit film sur ce dont je parlais ce matin, la transcription des téléconférences des sociétés américaines du Fortune 500. Et je demande à la régie d'envoyer le film.
Les récents progrès effectués ces dernières années, notamment dans le cadre de Quaero, permettent maintenant d'envisager des applications de plus en plus ambitieuses, telles que la transcription automatique de téléconférences. Prenons un exemple. Aux États-Unis, les grandes sociétés américaines du Fortune 500 organisent chaque trimestre des téléconférences avec leurs différents bureaux implantés sur tous les continents. Les transcriptions de ces téléconférences doivent ensuite être publiées dans des délais très courts sur les sites de ces sociétés. Nous devons être précis et rapides. La conférence est enregistrée par notre partenaire américain. Les différents enregistrements audio sont envoyés par paquet de 3 ou 5 minutes sur le service web de Vocapia. Les serveurs opérés par Vocapia convertissent le signal de parole en un texte brut qui est ensuite automatiquement enrichi par l'ajout de la ponctuation, de la casse et de l'écriture des montants et dates en chiffres. Notre partenaire réalise alors les seuls traitements non automatiques de la chaîne, la relecture et la correction par un humain pour publier une transcription vérifiée sans erreur. Enfin, ces transcriptions sont publiées sur le site internet des clients au plus tard 15 minutes après la fin de chaque téléconférence. À l'issue de chaque campagne, les données manuellement corrigées sont retournées à Vocapia. Nous les utilisons pour adapter nos modèles et diminuer ainsi le nombre d'erreurs de transcription pour la prochaine campagne, réduisant par conséquent les coûts de correction manuelle et donc les coûts de production. Le nombre de téléconférences traitées a triplé en un an.
Voilà, je vous remercie de votre attention.
Merci Bernard et Laurie. Donc on a 4 minutes pour les questions. Je vais m'approcher parce que je vois mieux quand je suis près du bord. Oui.
Je ne suis pas du tout spécialiste de la parole, mais néanmoins, vous avez parlé, François Solier, vous avez parlé du chinois, du mandarin. C'est une langue assez différente des langues européennes. You have spoken about English, about Chinese Mandarin. It is a very different language from the European languages in the sense that it has tones, lots of homophones. Can you comment on the difficulties?
Je peux même essayer de répondre en français, si vous voulez. On avait fait l'arabe et le chinois il y a assez longtemps, quoi. Ça fait peut-être 10 ans qu'on travaille dessus. Et oui, le ton, c'est différent, c'est un peu de challenge. À cette époque-là, on a introduit des features de pitch, des paramètres qui modèlent de pitch, l'intonation dans la phrase. Et depuis, on avait trouvé que ça marchait pour les langues qui ne sont pas les langues à ton. Et en fait, c'était très rigolo. C'était un peu un cross-fertilisation quand on avait découvert quelque chose qui marchait bien, qu'on a développé pour le chinois. Et ça marchait bien pour les autres langues. Une deuxième chose, pour le chinois, on avait aussi fait des modèles de challenge. Là. Pour le chinois, un des problèmes, c'est le fait qu'on ne sait pas les segmentations en caractères et mots. Du coup, c'est écrit sans les séparations et les outils qui existent qui font ça, plus ou moins, qu'on avait profité. Mais quand même, la notion d'un mot, c'est un peu différent. Et on a aussi fait des modèles des syllabes. Du coup, on a des séquences, ils s'appellent initial finals en chinois, qu'on a modélisé directement. On avait des résultats à peu près comparables que d'utiliser les modèles de phonèmes qui sont typiques dans les systèmes de langue européens. Sur l'arabe, la plus grande difficulté, qu'il y a beaucoup de mots qui ne sont pas écrits avec les voyelles. Et après, on a plein de prononciations pour un mot. Si on prend que les consonnes, on a plein de prononciations possibles pour les mots. Et du coup, on a un énorme espace de recherche d'essayer de trouver quelle forme doit sortir. C'est les deux grands challenges arabe et chinois. Je ne sais pas si quelqu'un d'autre a des choses à ajouter.
D'autres questions? Non? Là-bas, peut-être? Sûr, dernier appel? Oui, peut-être, non? Oui?
Oui, enfin à mon avis, moi j'ai fait un peu de chinois, un peu d'arabe, il me semble que la phonétique est beaucoup plus complexe avec l'arabe qu'avec le chinois. Et de toute façon, un étranger qui parle chinois, si votre système prenait en considération les tons, un étranger qui parlerait chinois ne serait pas transcrit. Donc de toute façon, le contexte... Non mais la question des tons, de toute façon, est résolue par le contexte. C'est beaucoup moins compliqué que ce qu'on veut bien dire.
Ça, je ne connais pas assez bien le chinois de pouvoir répondre, mais je ne pense pas qu'on avait beaucoup de données non chinois dans les données de tests de chinois. Donc c'est une bonne question, c'est bon, à voir.
Dernière question? Non? Ok, bien, merci. Merci Bernard.